Welcome to 2.4 formulas. So just at the top, there's a couple things that we would expect you to know as far as formulas are concerned. So one of them is the area of the circle, which is a equals pi r squared. One is the circumference of a circle, it's equals 2 pi r. Area of a rectangle, always going to be length times width. Area of a triangle, 1/2 base times height. And then the perimeter of any object is just the sum of the side lengths. That's how long it takes to get around that. So that's kind of what we're thinking about right there. Now, with this section, we're going to work with a couple formulas, but really this section is more about algebraic manipulation. That is, being able to have a formula and then manipulate it to solve for a letter. And it doesn't seem like we're going to be doing it, but really we're just using the addition principle and the multiplication principle of equations in a little bit more abstract way. So that is kind of what we're doing here. So what we have here is the first one says, consider this cube of side length s. So a cube, we assume that to be an object where all the sides are the same length. So if that's s, and that's s. So it's s tall, it's s wide, and it's s deep. So we have those three dimensions labeled right there. Okay. So we want to find the formula for the surface area of the cube. Okay. So the surface area, when we talk about the surface area, it's like, well, that is one of the faces of the cube. So we want to know how much area is there, and then really the question is how many faces does this have? So there's a front and a back, there's a left, a right, a top, and a bottom. So there's 6 sides of this cube, and each of them have the same dimensions. It's s by s. So once again, if we look, the area of a rectangle, and a square is just a special rectangle where the length and the width are the same, the area of this individual figure right there would be s squared. Since we have 6 of these, the surface area, SA, is going to be 6s squared, where s equals side length. So we didn't know what the formula for the surface area of a cube was, but we should know what the area, like what area is. Area is just was one face. We should be able to determine how many faces there are, and from that we can come up with the total surface area of the cube. Now the second part asks, what is the surface area when s equals 3 inches? Well, SA would equal 6 times 3 inches squared. So when we square 3 inches, we have 3 inches times 3 inches. So we have 9 inches squared. And we want to be really careful with the units, that we're using the proper units here. And square inches is right, because really when we talk about surface area, we're asking how many little 1 by 1 squares can we fit in this piece right there. Those are not great squares, but you kind of get the idea there. So 6 times 9, we got 54 inches squared. And that makes sense because area is always going to be in something squared. There's square units on that, so we want to make sure that we're looking good with that. Now this next one, it says the calorie density in calories per ounce of a food that contains C calories and weighs W ounces given by this formula here. So really they're saying nothing more than the calorie density is the calories per ounce. So like how many calories per ounce does something have? That would be something you could find as far as the nutritional information is concerned on just about any packaging of food. And, you know, if there's more calories per ounce, that could be a good or bad thing. I mean, protein has a lot of calories, so if you're trying to eat a lot of protein, calorie-dense food could be good. But if like ice cream is also very calorie-dense because it's high in fat. So we're just doing that. Now, this is the formula that we're given. Now they're asking us if 8 ounces of milk, so they're giving us a weight, 8 ounces of milk, contains 84 calories. They're giving us a calories here, where of course W is the weight, so we're going to put that in the denominator. C is the calories, we're going to put that in the numerator. We're going to find the calorie density of milk. So D equals 84 calories over 8 ounces. Now here's the deal. When we divide our 84 by 8, and when we do that, we are going to get a decimal here. We get 10.5 calories. Now when we do this, we divide our 8 into that. Really, we're getting a 10.5 here, and we're getting 1. So it's 8.5 calories per ounce. And, you know, division really means per, so 10.5 calories per ounce. And that's that one. So I'll pick it up on the next page with some solving for letters and equations.